Once upon a time, in a eukaryotic cell, there occurred the process of cellular respiration.
Nobody can live without cellular respiration. So here is a fun wave of education. With the 6-carbon glucose, we start this ride. During glycolysis, it does divide. But this reaction won't happen on its own. We need 2 ATP, just a small little loan. Forming 2 pyruvates, 2 NADH, and 4 ATP. You better not disagree. There would be no life without cellular respiration. This is our foundation, taking place in the cytoplasm, said the teacher with no sarcasm.
This party moves to the mitochondrial matrix, so stick with us and have some patience. We input the pyruvates from the process before. Just add 2, no less, no more. Acetyl-CoA synthesis is the enormous name of the second phase of this essential game. Its importance may seem at first quite small, but its inputs are not minor, not at all. NAD+ forms some nice little bonds with hydrogen atoms and energetic electrons. 2 acetyl-CoA, 2 NADH, and 2 CO2, almost like a recipe for a delicious stew.
The next process is citric acid cycle, and like everything else, it is vital. Also taking place in the mitochondrial matrix. Learn this because these are the basics. The only input is 2 acetyl-CoA. Stay with us now and don't hit the hay. It is many reactions that go around and around, and our input changes from compound to compound. To the end of the circle where they regenerate, our starting reactant oxaloacetate. Electrons are lost and they need a new home. Bonding with NAD and FAD, they no longer roam. The list of products is quite the queue. The outputs are 6 NADH, 2 FADH2, 2 more ATP, and 4 CO2. If you're just learning this, it's a little overdue.
The last process is called electron transport chain, and hopefully it won't be too much of a strain. The inputs in this are many, but its outputs are plenty. Simply add 10 ADH and 2 FADH2, and count all of the electrons they bring too. Don't forget those membrane proteins, complexes 1 through 4. They let protons in, electrons out, and so much more. In complex 4, 6O2, electrons and hydrogen are all bonded together once again. Hydrogen protons flow through the intermembrane space until they reach the enzyme ATP synthase. There, electrochemical energy causes the protein to spin, and then ADP and phosphate bond in. The formation of ATP while protons go back into the matrix. Into there they flow. It's up to you to gauge the importance of this stage, giving off a whopping 6 H2O and 32 ATP, making everybody say whoopee, taking place in the mitochondrial inner membrane, making all the bio students go insane.
The end.